So today we start module 2. The topic is dependability, performance, and principles. You can see we will learn 3 topics in this module. Part A, dependability and reliability. Before we start this topic, I want to do 2 examples from Part D of Module 1. Because in Part D, we didn't have enough time to do examples. So in our Part A.1, so we will do 2 examples on dynamic power and dynamic energy. All right, so let's look at our first example. Example 6. Here I use the sequence, for this class, 1, 2, 3, consecutive numbers. So here we have example number 6. The question: the power savings in a server system can reduce the electricity bill. There are 2 plans to reduce the power. Okay? The plan A, reducing the voltage by 15%. Voltage by 15%, while keeping the same frequency. Plan B, reducing the frequency by 25%, while keeping the same voltage. Now we want to compare these 2 plans. So which one can help us save more electricity bill? So that's the question. So pretty simple. But to solve this even simple question, you need to use the right formula. If you know the right formula, then the solution is pretty straightforward. So here, let us get the right formula first. Power. So you see this power. And actually, it's dynamic power, not static power. So it is the dynamic power. So let us get the dynamic power formula. It's this one. Okay. Proportional. Hope you still know the meaning of this proportional meaning. All right. Because this part, basically, the constant. So we do not worry about the constant. Here we want to compare under these 2 plans, which one can help us save more electricity bill. Okay, all right. When we use the dynamic power first we know electricity bill associated with energy. Right? The energy consumed, then that part related to the, electricity bill. Although we know energy related to the power. Here, we need to understand in this way. When we reduce the power, we can still do the same amount of work. Because the power reduced. So think about the CPU. Old CPU, new CPU. The old CPU usually consumed more dynamic power. And the new CPU consumed much less dynamic power. Right? But if you compare the processing work they can do, the new CPU can even do more than old CPU, right? The dynamic power reduced, but the productivity actually could be increased, right? So here we assume even the dynamic power reduced, but we can still do the same computing. So let's start the work. So this side plan A, this side plan B. Now, let's compute the saving part under each plane, how much dynamic power saved. Under the same productivity, dynamic power saved. Let's do that calculation. All right. In order to do that, we need to assume we start with, initially, before we do the improvement, dynamic power is P0. Okay? All right. So then plan A, dynamic power PA. PA, the saving part based on the number given here, okay? Yeah. Voltage reduced by 15%. Voltage, look at the square factor reduced by 15%. So we should get a change like minus 15% square. Okay? Yeah. All right. So let's do the calculation. 0.85, right? Square, P0. All right, yeah. So then let's do the calculation, approximately 0.7225 P0. Okay, yeah. With this plan, the dynamic power will be reduced to the 72.25% of the original number. All right. So now let's go to the plan B. For the plan B, PB, so this time from that original dynamic power, but this time we do the change at the frequency part. But the frequency, there is no square, right? So we only need to use the factor once, yeah, not twice. Yeah. So that is 1 minus 25%. So that is approximately 75% of P0. At the end, we compare these two numbers. Which one gives us more saving? The answer is obvious. This one is smaller, right? Smaller, that means we have more saving. So the answer, plan A, is the choice. Plan A is a better plan. Yeah. So that is our first example. Yeah. All right. So next, example number 7. Yeah. In this one, we want to do the dynamic energy. Slightly different, yeah, but similar dynamic energy. Yeah. So look at this question. We compare the dynamic energy consumption of a module in two different states, state A and state B. For state A, the voltage of the module is stable in V in 2 hours. Wow. So we measure these two different states, yeah, A in the same period of time. Yeah. So hour 1, hour 2. Yeah. 2 hours. Okay, all right. Hour 1, V stable. Hour 2 also V stable. All right. So now state B, the same period of time, hour 1, hour 2, but the voltage different. First hour 1 minus 8% V. Second hour 1 plus 8% V. Okay, all right. So now we need to compare these two states. Which one gives us, yeah, right. will consume less. Yeah. So we want to get the one with less dynamic energy. Which state consumes less dynamic energy? Yeah. So let's do the comparison. All right. Yeah. So for the A state, dynamic energy. Yeah. But we need to get the formula first, right? Before we do the calculation. Yeah. So here, yeah. So let me use this formula. Dynamic energy, constant, proportional to constant, then voltage squared. So that factor, voltage squared, per hour. Yeah. So let's assume, yeah, because the energy we consumed in that period of time, yeah. Okay. All right. Yeah. So A, so let us use the energy EA. How about that? EA equals, compare with the original state, so E0, okay? E0, all right. Then, the first hour, when you use V, you get E0. Second hour, you also use V, you get E0, right? So that's 2E0. That's simple, okay? Yeah. So we assume E0 is the energy consumed for each hour. How about that? Each hour with voltage V number. Yeah, that's our assumption. Yeah. All right, so then the B state. B state, EB this time. Yeah. E0, now voltage square. So that is minus A% square. Okay, all right. The second hour, E0, 1 plus A%. How about that? Yeah. So can you do simplification? Yeah, so I hope you can do simplification. Equals E0 expand using the formula, right? So you will get 2, the minus plus cancel out, plus 2 times A% square, okay? Yeah. Just some A number squared, yeah. Some positive number squared. So you can see this number is greater than 2E0. How about that? So yeah, because here let us assume A greater than 0. Okay, A greater than 0. So the answer for the state B, that number greater than state A number. So the conclusion, state A consumes less dynamic energy. Yeah, so A is the winner. Yeah, so that's the way we use these formulas to solve some related questions. Yeah. All right, so hope you can understand. Yeah, later we have many similar questions similar to these examples. Yeah, try to using this kind of analysis to solve them. Yeah. All right, so let me stop here. Yeah, our first video.